this recording, we're going to learn how to solve fractional or rational equations. I'll give you a second to write that, heading down that first example. We're going to solve this equation by eliminating any fractions. Some people here in this case, seeing a proportion, would say, well, you just can cross multiply. And you can, as long as you know that it's a proportion. But I'm not going to suggest that technique. I'm going to give you a technique that's going to work for any fractional equations, even those that aren't proportional. And we're simply going to eliminate the fractions, just like we did with our complex fractions. We see the denominators, 2 and 5. We say, what's the LCD out of 2 and 5? And we multiply all terms by that LCD. Of course, that LCD is just 10 because they don't share any factors. So if I multiply both sides by 10 over 1, I don't have to write the 1. In fact, I probably am not going to do that in the future. I'm just going to write the 10. Multiply both sides by 10. The nice thing is the 10 divides out both the 2 and the 5. So 10 over 2 is 5. 10 over 5 is 2. Okay? Then you just distribute the 2 to x minus 1 and distribute the 5 to 4x plus 5. And you get this. Okay? So we're going to multiply all terms by the LCD to eliminate the fractions. When you distribute the 5, you get 20x plus 25. Distribute the 2, you get 2x minus 2. Go ahead and solve this for x, and play the recording once you've done so. Okay, so hopefully you subtracted 2x from both sides, worked it all out, and ended up with x equals negative 3 halves, or an x equals negative 1.5. Either form is fine. Now this wasn't a rational equation because it didn't have an x in the denominator, but it's a good place to start. It's a fractional equation. Okay. Our next example is a rational equation. It does have x's in the denominator. So as you write it down, I want you to think here. What values of the variable would make the fractions undefined? And I'd like you to jot those down. Okay, so we've got this equation, and we want to say what values can't x be? X can't be what? Well, here, something that's going to make the denominator equal to 0 would be a 2, right? And over here it would be a 6. So x cannot be 2, and x cannot be 6. Those are bad news. So if we get answers of 2 or 6, we will eliminate them. They're what we call extraneous solutions. So we want to think about that ahead of time. I strongly encourage you to think about that ahead of time so that when you get those answers at the end, you'll be prepared for them and you'll eliminate them. Here, think about what your LCD would be. Well, there's no way to factor 2 minus x, and there's no way to factor x minus 6. So simply, the LCD is just the product. 2 minus x times x minus 6. So jot this down, please. If the denominators don't have a common factor, the LCD is just their product, just like it was up above. 2 and 5 don't share a common factor, so our LCD is just the product, 10. Cool. So the way we're going to do this is we're going to multiply both sides by that LCD. 2 minus x times x minus 6. Okay, so put that in parentheses above all the terms. This is one term, this is the other term. 2 minus x, x minus 6. Because in an equation, we're allowed to multiply both sides by the same thing, right? To maintain the equality. Well, that's cool because the 2 minus x just divided out, and so did the x minus 6. And we're left with no fractions. So you're simply going to distribute the x minus 6 to the x plus 1, and the 2 to the 2 minus x. I would like you to proceed to distribute this all out, solve for x, get as far as you can, and then play the recording once you've got your values of x. Okay, so hopefully you got as far as you can. If not, please pause and do that now. Distribute it out, get all the terms on one side, right? When we solve a quadratic equation, something with a square in it, we want 0 on one side. Hopefully this looks factorable to you, okay? X minus 5 and x plus 2 equals 0, and those are our two values. Can you remember before what we had was x could not equal 2, and x could not equal, I'm sorry, 6. Those are our two values. We did not get either of those values, so we do not need to eliminate either answer. Both those answers would check. Time permitting, we could sub the 5 back in, make sure it checks, sub the -2 back in. We can also talk in class about how to use the calculator to check that. Okay? All right, let's get into a more complicated example, one that has several terms. We're still going to try to do the same thing. We're going to try to get rid of the little fractions, get into an equation that has no fractions. Try to multiply all terms by that LCD. All right? So in this case, it looks like the LCD, well, we have to look at the numbers, has to have a 10 and a 5 in it. So I'll say, well, the lowest number that they both go into is 10. Then for the variables, I look for the largest exponent. So x squared would be part of the LCD because x goes into it, as does x squared. X could not be the LCD because x squared does not go into x. It's not a multiple. Okay? X is not a multiple of x squared. As before, I'm going to change any subtraction into addition of opposites. That's going to matter sometimes, even if it doesn't matter here. Okay? So I'm going to multiply all my terms by 10x squared. So come in here with a 10x squared, multiply all terms by it. Just write it right above there. Okay. Now that we've got our 10x squared, this is the fun part, dividing out to eliminate the fractions. 10 over 10 is deleted. I just have x squared times 1. I'll write that down. X squared over x just leaves an x. So I have a -1 times 10x. That's minus 10x. Next, 5x. 5 and 10 divide out to leave a 2. X squared and x divide out to leave an x. So I have a 1 times 2x. It's 2x. Finally, x squared. I have a -2 times 10. That's a -20. That looks like something you can solve. Solve this. Play the recording once you've got your answers. Okay, so hopefully you played the recording. It just occurred to me we didn't do something that I said we were going to do before we start each question. We were going to think what values of the variable would make any of these fractions undefined. Because there's only x and x squared in the denominator, the only value x cannot be is 0. So if I get a 0 in here, I know I've got an extraneous solution. Okay? In order to solve this, bring all your terms over to one side. So we're going to go x squared, we're going to subtract, so we've got minus 12x plus 20 equals 0. Looks nice and factorable, so x minus 10, x minus 2 equals 0. Therefore, x is 10 and x is 2. That did not occur as one of my solutions, so I'm pretty confident that I've got it. Of course, I could sub them in and check. Here are our steps I'd like you to copy into your notebook, please. Basically what we just did, we identified the LCD, we multiplied all the terms by the LCD, and then we simplified to eliminate the fractions. You'll know you've got the right LCD if you eliminate all your fractions. Then we solved. Whether it's a quadratic or linear equation, we solve for x. Finally, we check for extraneous solutions, ones that would make the denominator equal to 0. So copy those steps down and play a recording when you're ready. Okay, at our next example, I'd like you to get as far as you possibly can. It's very similar to the one before. Then play the recording when you're ready. Okay, so hopefully you got as far as you can here. Our LCD is going to be 4x squared, right? So we're going to multiply all the terms by 4x squared. Come in and multiply all those, 4x squared, etc. Okay, change it to an addition of opposites. Let's divide out everything that we possibly can. That's just going to leave a 2x squared. That's going to leave an x. X squareds divide out. 4x, that's just going to leave an x up top. That's just going to leave us with a 2. Okay? Great. So 2x squared. Notice all my denominators are gone. They're all divided out. 2x squared in the first term, 12x minus 4 equals x plus 2. Go ahead and solve that. Well, to solve that, you need to get a 0 on one side. I'd like you to get a 0 on one side, factor it, or use your quadratic formula if you're so inclined. Then play the recording when you're ready. Hopefully you got as far as you could with this. Get a 0 on one side. Now this is one of those where I want to use the window because I have a leading coefficient of 1. I'm going to go 2 times negative 6 is negative 12. I need to add up to 11, which would be 1 and negative 12. I'm going to make my window. So in that case, my window looks like this. My factors, 2x minus 1 and x plus 6. Set them equal to 0, each one of them, and solve. Again, I should have set up here what x couldn't equal, and that would have been 0, right? That's the only number x couldn't equal. I did not get as a solution, so it's no problem. They both check. Okay. Last example we're going to consider together. This one says solve and reject any extraneous root. So right away I'm sort of inclined to think I might have an extraneous root, but let's say what they might be. First I'm going to need to factor this middle fraction. So as you're writing it down, I'd like you to try to factor out this middle fraction's denominator. Then play the recording when you're ready. So hopefully you got here an x plus 3 and an x plus 5. So jot down over on the side here, what are the numbers that x cannot be that would make us divide by 0, that would make a fraction undefined? Crossing this out because I just replaced it with its factored form. Hopefully you said x cannot equal negative 5 and x cannot equal negative 3. Those would be bad news, right? They would both cause the denominators to equal 0. So my LCD in this case would be x plus 3, x plus 5. Okay? Multiply each one of them by x plus 3, x plus 5. I'll use some purple here. X plus 3, x plus 5. Multiply that by all three. So we're going to eliminate all our fractions. The x plus 5 divide out, x plus 3 and x plus 5 divide out in the middle, and x plus 3 all by itself divides out. Nice. Notice all my denominators are gone. I just have the top part left. Doesn't mean it's easy, but it sure got a lot better. Okay? When I multiply out x plus 3 times x plus 1, I have to distribute out, and I get this. X squared plus 4x plus 3. 18 is just left, so plus 18. Then distributing the 9 to the x plus 5, I get 9x plus 45. Would like you to get all the terms on one side, factor and solve, and please play the recording only when you've gotten as far as you can. Okay, so hopefully you got as far as you can, otherwise pause the recording and don't play it yet. Alright, I'm going to get a 0 on one side. This is nice and factorable. X minus 8, x plus 3. Bring my screen up just a little bit so I can see these numbers in the top hand corner here. Alright, it looks like my answers are 8 and negative 3, but I'm going to reject x minus 3 because that is one of those numbers that I said would cause me to divide by 0. Okay, so we call that extraneous. An extraneous solution is an apparent solution. It means it appears to be a solution, but it just doesn't check. I didn't make any math mistakes in here, but I have an answer that doesn't check out because if x is equal to, this should say negative 3 here, the last fraction would be undefined. Well, so would this one too, the one that's got that as a factor. So that's always something we want to look for when we are solving rational equations. Thanks for watching.